In last module, we had discussed about the processor organization. So, what do you mean by a processor organization, or what are the methods that are used for implementing a processor? All these are discussed in last module. So, here in next module, we can discuss about control logic design. So, what do you mean by a control unit? In a digital system, we had two main components. One is a data processor or a processing unit, as well as a control unit. So, what is the function of this control unit? Control unit, it is a circuit which initiates some micro operations, or it provides some control signals to the processing unit. So in this figure we can see there are two main components are there. One is data processing unit as well as control logic, and the figure shows how these two components are related. Okay. What is the function of data processor? Which accepts some input data and it processes that data and it will produce some output. Okay. Actually that processing is operation that is performed on the data, and the operations, they are known as micro operations. And who initiates this micro operation? Control logic or control unit which initiates these micro operations. So control logic which initiates micro operations, operations that processing is done in data processor, and it will generate some output data as well as some status conditions. All these status conditions are fed back to control logic. Okay, control unit. And these control units which can accept or access external inputs also. So this is the relationship between a control unit and a data processing unit. Okay. Next we can move on to control organizations. So before that, this is the explanation. Data processor is a general purpose processor unit which consists of individual register. Also it processes some micro operations, and control unit which initiates all micro operations. So the control logic that generates signals for processing unit, or it generates signals for sequencing the micro operation in a sequential circuit whose internal states indicates the control function for the system. So these are all about the introduction part, or how the control unit is associated with the processing unit. Okay, and next we can move on to control organization, or the methods of control organization, or how the control unit is implemented, or how the control unit is organized. There are four methods for implementing a control unit, or there are four methods for a control organization. First one flip-flop per state method. Second one, a sequence register or decoder method. Third one, a PLA control, and fourth one, it's a microprogram control. So there are four methods for implementing a control unit. First one flip-flop per state method. Second, a sequence register and decoder method. Third one, a PLA control, and fourth one, a microprogram control. Clear? So in this first two methods that uses SSI and MSI circuits for implementing. First two methods are one flip-flop per state method and sequence register and decoder method. And these two methods uses SSI and MSI circuits for implementing. Also, these circuits are interconnected by various number of wires. So these two methods are known as a hardwired control method. Okay, and the other two, they are PLA control and microprogram control, which uses LSI device for implementing, such as programmable logic array that is used in PLA control, and a special ROM is used in microprogram control. Okay, so there are four methods for implementing a control organization. First one flip-flop per state method. Second, sequence register and decoder method. Third one, PLA control. And fourth one, microprogram control. In which first two methods, which uses SSI and MSI circuits, also a number of wired connection is there. So they are known as hardwired control mechanism. And the third one and fourth one, which uses LSI device for implementing, such as programmable logic array as well as ROM. Clear? So we can move on to first method, that is one flip-flop per state method. So in name itself it indicates that this method uses a number of flip-flops, but only one flip-flop is set at any particular time. All others should be cleared. That is, if we are using a 4 flip-flops in a circuit, one flip-flop is set at a time t1, that is, it is equal to 1 at time t1, but at time t1 all other 3, they are cleared or they are set as 0. That is the meaning of one flip-flop per state method. So this method in control unit, the main component is flip-flops. Clear? And what are the advantages of one flip-flop per state method? Main advantages, it is its operational simplicity. Also, it has a potential to decrease in the combinational circuit required to implement the complete sequential circuit. So this is the main advantage. So in one flip-flop per state method, we can use a number of flip-flops. Only one will be active at any time. All others should be cleared. And the main advantage is simplicity and potential decrease in the combinational circuit for implementing. Clear? And this is the architecture of control logic with one flip-flop per state. So the main component is a decision logic which access or accepts external input conditions and other control outputs. Also, other component in this method is 4 D-type flip-flops. Okay, so this is the architecture of one flip-flop per state method, which contains decision logic component as well as 4 D-type flip-flops, in which the decision logic which accepts external input conditions as well as other control outputs. Clear? So here only one flip-flop is equal to 1 at any time. All others should be cleared to 0. And each of the flip-flop output is connected to data processing section of the digital system to initiate some micro operation. Here other control inputs and external inputs are there, which is accepted by the decision logic. If the circuit does not need any external input condition, then the circuit is changed to a shift register for just implementing a single bit shift operations. But if the control sequence must be repeated over and over again, this control unit reduces to a ring counter. So this ring counter is also a type of shift register, but the shifting operation is in circular manner. For this reason, this method is called as ring counter controller. So first method എന്ന് പറയുന്നത് one flip-flop per state method. അതിലൊരു decision logic component ഉണ്ട്, അതുപോലെ 4 D-type flip-flops ഉണ്ട്. Decision logicിലേക്ക് വരുന്ന ഇൻപുട്ട് എന്ന് പറയുന്നത് എക്സ്റ്റേണൽ ഇൻപുട്ടോ അല്ലെങ്കിൽ അതർ കൺട്രോൾ ഇൻപുട്സോ ആയിരിക്കും. ഓക്കെ, ഇനി ഈ ഡി ടൈപ്പ് ഫ്ലിപ്പ് ഫ്ലോപ്പിൽ നിന്ന് പുറത്തേക്ക് വരുന്ന ഔട്ട്പുട്ട് അത് എവിടത്തേക്കാണ് കണക്ട് ചെയ്തിട്ടുണ്ടാവുക? പ്രോസസ്സിംഗ് യൂണിറ്റിന്. കൺട്രോൾ യൂണിറ്റ് പ്രോസസ്സിംഗ് യൂണിറ്റിലേക്കാണ് കണക്ട് ചെയ്യേണ്ടത്. സോ പ്രോസസ്സിംഗ് യൂണിറ്റിലേക്ക്, പ്രോസസ്സറിലേക്കാണ് കണക്ട് ചെയ്തിട്ടുണ്ടാവുക. ഓക്കെ, എന്തിനു വേണ്ടിയിട്ട്? അവിടെയാണ് മൈക്രോ ഓപ്പറേഷൻസ് ഓപ്പറേറ്റ് ചെയ്യപ്പെടേണ്ടത് അല്ലെങ്കിൽ പ്രോസസ്സ് ചെയ്യപ്പെടേണ്ടത്. ഇനി ഈ കൺട്രോൾ സർക്യൂട്ട് എക്സ്റ്റേണൽ ഇൻപുട്ട് യൂസ് ചെയ്യുന്നതിൽ ഇല്ലെങ്കിൽ ഈ സർക്യൂട്ട് ഒരു ഷിഫ്റ്റ് രജിസ്റ്റർ പോലെ ആക്ട് ചെയ്യും. ഒരു സിംഗിൾ ബിറ്റ് ഷിഫ്റ്റ് ഓപ്പറേഷന് വേണ്ടിയിട്ട് യൂസ് ചെയ്യും. അല്ലെങ്കിൽ കൺട്രോൾ സീക്വൻസസ്, അതായത് എക്സ്റ്റേണൽ ഇൻപുട്സ് ഓവർ ആൻഡ് ഓവർ എഗെയിൻ അത് യൂസ് ചെയ്യുന്നുണ്ടെങ്കിൽ ഈ സർക്യൂട്ട് ഒരു റിംഗ് കൗണ്ടർ ആയിട്ട് ആക്ട് ചെയ്യും. ഓക്കെ, റിംഗ് കൗണ്ടറും ഒരു ടൈപ്പ് ഓഫ് ഷിഫ്റ്റ് രജിസ്റ്റർ ആണ്. ബട്ട് സർക്കുലർ മാനറിലാണത് ഷിഫ്റ്റ് ചെയ്യപ്പെടുന്നത് ബിറ്റ്. അതുകൊണ്ട് തന്നെ ഈ മെത്തേഡിനെ വേറൊരു പേരിൽ കൂടി അറിയപ്പെടുന്നുണ്ട്, റിംഗ് കൗണ്ടർ കൺട്രോളർ. ഓക്കെ, these are all about one flip-flop per state method. Okay, this is the first method for implementing a control unit. And the second one, it's a sequence register and decoder method. This method uses a sequence register, and the register is decoded to provide one output for each state. If you are using n flip-flops in sequence register, it will have a 2n states, and the decoder will have a 2n outputs. Okay, if a 4-bit register is used, we can get a 16 states. So in a sequence register and decoder method, the architecture is the main component is the decision logic along with this sequence register and a decoder, and this sequence register which is implemented by using flip-flops. Okay, and here decision logic which accepts external input conditions as well as other control outputs, and the decoder output which is fed back to decision logic. Okay, if we have a 4-bit sequence register and we have 2n states and 2n decoder outputs are there. Clear? So this figure shows the configuration of a 4-state sequential control logic, and the sequence register has 2 flip-flops, and decoder establishes separate outputs for each state in the register. If the control circuit does not need external input, the sequence register reduces to a counter. So this is called a counter decoder method. So next method എന്ന് പറയുന്നത് sequence register and decoder method. ഒരു decision logic ഉണ്ട്, sequence register ഉണ്ട്, decoder ഉണ്ട്. sequence register എന്ന് പറയുന്നത് 2 flip flop കൂടിയിട്ടുള്ള sequence register ആണ് ഇവിടെ പറഞ്ഞിരിക്കുന്നത്. സോ 2 flip flop ആണെങ്കിൽ അതിനുള്ള സ്റ്റേറ്റ് എന്ന് പറയുന്നത് 4 സ്റ്റേറ്റ് ആയിരിക്കും. അതുപോലെ തന്നെ 4 decoder ഔട്ട്പുട്ടും ഉണ്ടാവും. decision logicന് external ഇൻപുട്സിനെയും ആക്സസ് ചെയ്യാം, അതുപോലെ അതർ കൺട്രോൾ ഔട്ട്പുട്സിനെയും ആക്സസ് ചെയ്യാം. ഇനി ഈ കൺട്രോൾ സർക്യൂട്ട് എക്സ്റ്റേണൽ ഇൻപുട്സിനെ ആക്സസ് ചെയ്യുന്നില്ലെങ്കിൽ ഇത് എന്തായിട്ട് ആക്ട് ചെയ്യും? ഒരു കൗണ്ടർ സർക്യൂട്ട് ആയിട്ട് ആക്ട് ചെയ്യും. അതുകൊണ്ട് തന്നെ ഇതിനെ പറയുന്ന പേരാണ് കൗണ്ടർ ഡീകോഡർ മെത്തേഡ്. സോ what do you mean by a control unit and how it is related with a data processing unit? Next, what are the methods for implementing a control unit, or 4 methods for control organization. First method is one flip-flop per state method. Second, sequence register and decoder method. Okay, thank you.